Next we have theorem 6.10.3 where we have a Hermitian operator again T on some finite dimensional inner product space V. We now have to prove that all the characteristic roots of T are real numbers. So we start the proof by considering any characteristic root lambda of T. Then by definition, there exists a non-zero vector V in V such that the T image of V equals lambda V. This V is a characteristic vector corresponding to lambda. Now next you consider this calculation. We considered lambda times the inner product of V with itself. By one of the properties of inner product, actually by definition, you can push this lambda inside with the first component. Because, if you interpret it the other way, if you take lambda out from this first component, then simply lambda comes out. But if you want to take a scalar out from the second component, then its complex conjugate comes out. Alright. Now lambda V is Vt, and you already know that you can push this T to this second component, then it gets replaced by its Hermitian adjoint. T star. But what is given? It's given that T is Hermitian or self-adjoint. That means T star equals T. So you have now Vt in the second component, which is just lambda V. And now from this second component, if you want to push lambda outside, then its complex conjugate comes out. So you get the fact that lambda times the inner product of V with itself equals the complex conjugate of lambda times that same inner product. And next we note this, that since our vector V is non-zero, so the inner product of V with itself is non-zero. You go back and see the definition of inner product. It becomes zero only when the vector is zero. That is precisely the case when the inner product of a vector with itself is zero. And that is why we can cancel this inner product from both sides of this equation, obtaining this fact that lambda equals its complex conjugate. Note carefully that because our vector space has the underlying field, the field of complex numbers, which is an algebraically closed field, so all eigenvalues of any operator on our space are complex numbers. That's already there, so that's why lambda is in general a complex number. But because of this fact, now lambda becomes a real number. So that's how any characteristic root of T is a real number.